What we're going to look at here is a combination between the converse of the Pythagorean theorem. In other words, if we have three numbers as lengths of the sides of a triangle, do they represent lengths of the sides of a right triangle? Or our other two theorems that allow us to determine, well, if it's not a right triangle, is it an acute triangle or is it an obtuse triangle? Remember from last year, we even have a theorem that lets us determine whether or not the three sides even make a triangle. Remember that we have something called the triangle inequality theorem, which says that the sum of the lengths of any two sides has to be greater than the length of the third side. Now, technically, we really don't need to do that except to check the two shortest sides. So, in our directions here, determine whether each set of numbers can measure the side of a triangle. If so, classify the triangle as acute, obtuse, or right. So, first of all, will those three sides even be a triangle? And if so, let's determine what kind. So, on A here, we have lengths 5, 8, and 11. So, first of all, we just checked. 5 plus 8 equals 13, and that's greater than 11. So, we do have a triangle. Now, what we want to do is we want to compare the squares. So, 5 squared plus 8 squared. We want to find the sum of the squares of the shorter sides. So that'd be 25 plus 64, which gives us 89. If I square 11, I get 121. So is that a right triangle? No. The sum of the squares of the two shorter sides did not equal the square of the longer side. But what we see is that sum is less than the square of the longest side. In other words, the third side is too long to be the hypotenuse. If that's the case, then what we have is an obtuse triangle. So in order to be a right triangle, the third side, if we squared it, would have to equal 89. This one's bigger than that. It's too big to be the hypotenuse of a right triangle. Okay, moving on to B. Here, if I add 3 plus 7, I get 10. Oh, 10 is not greater than 10. So there is no such triangle. Remember, the two shorter sides have to have a sum that's greater than the third side. If they're equal, no, there's no triangle. So I wouldn't need to go any further with that one. On C, if I add the two shorter sides, 16 plus 30, I get 46. 46 is bigger than 34, so yes, we have a triangle. Let's see, 16 squared plus 30 squared. Remember, if it is a right triangle, the longest side would have to be the hypotenuse. I don't know whether or not this is a right triangle. I'm just trying to see. So 16 squared is 256. 30 squared is 900. 256 plus 900 is 1,156. If I square 34, I also get 1,156. So this one is a right triangle. Because if I find the sum of the squares of the two shorter sides, it does equal the square of the longest side. All right, finally, example D. If I add 9 and 11, I get 20. 20 is greater than 13. So yes, I have a triangle. Notice in each case, I am demonstrating how I know I have a triangle or not. So I'm showing my work. I'm showing my steps. Okay, if this is to be a right triangle, 13 is the longest side and would be the hypotenuse. Not saying it is the hypotenuse. I don't know if I have a right triangle or not. But it's a possible hypotenuse. So if I take 9 squared plus 11 squared, the sum of the squares of the two shorter sides. 9 squared is 81. 11 squared is 121. So when we add those two together, we get 202. If I take 13 squared, I get 169. In this particular case, the sum of the squares of the two shorter sides is bigger than the square of the longest side. What we're saying here is that the third side is too short to be the hypotenuse of a right triangle. So that's saying then that our triangle is an acute triangle. If it's too short to be the hypotenuse, then the angle opposite that has to be less than 90 degrees. So we have to have an acute triangle here. If we do have an obtuse triangle, the longest side has to be opposite the obtuse angle. So 13 is the longest side. It's not opposite an obtuse angle because it's not big enough. It's not opposite a right angle. It's not big enough. So the triangle has to be acute.